All right, so today we're going back to the video lessons, and you are going to be doing, this is target 9A, writing and applying recursive and explicit formulas. So we take a little bit of a break from what we've been doing with functions and graphing, but don't worry, we will get back to it this unit. All right, so let's start off with our objectives. You will be able to write a recursive expression. You will be able to apply a recursive expression to determine the solution of real-world examples. And you will be able to write an explicit expression and eventually solve problems using that. And you'll be able to apply an explicit expression to determine the solution to real-world examples. All right, so let's start off with some vocabulary. Okay, sequence is an ordered list of numbers. Okay, so when you hear me use sequence, that's what I'm referring to. And a term is a number in the list of the sequence. So specific to this unit, when I say term, that's what I'm talking about. All right, so notations that you're going to want to know for sequences. The first term of a sequence is denoted or called a sub 1. Okay, the second term is a sub 2, the third one a sub 3, so on and so forth. You get the idea. Okay, the term in the nth position, meaning n could be anything, so we just call it the nth, is denoted or called a sub n. So when we write it as a formula, that would be like our variable, so to speak. And the term before a sub n is called a sub n minus 1. And that's important to note because you're going to be using that quite a bit. Okay, so here's an example. We've got a set A, and the numbers in that set are 1, 3, 5, 7, 8, etc. The 3 dots there mean it basically goes on. Okay, and then we've got the first term, second term, and third term. So the first term obviously would be a sub 1, which is 1. Second term would be a sub 2, which is 3. Third term would be a sub 3, which is 5. So you can see the terms here. We've got 1, second term, third term. And then if we wanted to find the nth term, that's basically where this recursive formula comes in. And that's where you say a sub n equals a sub n minus 1 plus 2, because each time we're taking the previous term and adding 2 to it. Okay, so hopefully that makes a little bit of sense. Something that is important to know about this is what is recursive formula, because that a sub n formula I showed, that's a recursive formula. And it's a formula that provides a method for generating the terms of a sequence where the value of each subsequent term, meaning each following term, is determined by performing some type of operation on one or more of the previous terms in the sequence. That's really wordy. I know that. But just take notes on it the best you can. Put it in your own words. And then with the recursive formula, now this is important to know. In order to know, say, the value of the 100th term, you need to already have the value of the 99th term. And to know the 99th, you need to know the 98th. You basically need to go all the way back to the first term to figure out each one. So that's one of the main ideas with the recursive formula. Okay, here's how you write it. So let's say we have the sequence -4, -1, 2, 5, so on and so forth. We need to write a recursive formula and find the 5th term in the sequence. Now you can probably look at it and say, well, I can tell right away what that 5th term is going to be, but the tricky part's going to be writing the recursive formula. So the first thing to do is determine what a sub 1 is. Okay, this is going to be the first term listed in the sequence. So in this case, that's right there, that -4. Okay, and a sub 1 equals -4. That's how we write that. The next thing to do is we need to figure out what's happening each step after that. Well, from here to here, I'm adding 3. From here to here, I'm adding 3. So another way to look at it is write down those terms that you know. Say, okay, what's going on in between those terms? In this case, like I said, we're adding 3 each time. So -4 plus 3 equals -1. -1 plus 3 equals 2. 2 plus 3 equals 5. And you can see how we have to know the previous term in order to find that one. And the third thing we need to do is write a recursive formula for a sub n. So we need to write a formula that basically tells us what's going on here. So to do that, we say a sub 1 equals -4, okay, because that's what we started with, was this right here, okay? And then, so you have to state whatever your first term is. You just can't write an equation and have that be it. Okay, then you say a sub n. So when they have you write a formula, it's always going to be a sub n equals something. Okay, in this case, it's the previous term, which we say is a sub n minus 1. And since we're adding 3 each time, that's where that plus 3 comes in. So the fifth term, since we know the fourth term is 5, would be 8. So what you would do is you could say a sub, that would be 5, equals a sub n minus 1. So the fourth term, so because it's 5 minus 1. What's the fourth term? Would be 5 plus 3, and that would give you 8. So let's say I needed to find the sixth term. I would need to do this again and say like a sub 6 equals 8 was my previous term, because this one right here is a sub 6 minus 1, which is a sub 5, which we figured out to be 8. And that would be plus 3. And the answer to that one would be 11. So hopefully you get the idea from that. All right, so now we have to apply this. Let's write a recursive formula for the given situation. So all we're doing is writing the formula. So a basketball is dropped from a height of 100 inches. The first bounce reaches a height of 50 inches. The second bounce reaches a height of 25 inches, so on and so forth. So first things first, determine what a sub 1 is. That's the first term. In this case, it's the first number they give you, the starting point, the initial height or whatever. Okay, so a sub 1 equals 100. Second thing, again, determine what's happening each step after that. So after this 100, we have a 50 and we have a 25. So what's happening between those three numbers? Well, your first instinct might be to say, well, I'm subtracting 50. If I did minus 50, that would give me 50, but I would have to do the same thing again. 50 minus 50 would equal 0, not 25. So how else could I get 50 from 100? Well, we can divide by 2. 100 divided by 2 is 50. Let's see if it works for this one. 50 divided by 2 is 25. So we're dividing by 2 each step. Okay, the third thing we have to do is write a recursive expression for a sub n. So again, you start off with what a sub 1 is, which is 100. And then you say a sub n equals the last term, the term before it. So 50, in the, if I was to write it for this, 50 divided by 2 equals 25. So a sub n minus 1, whatever the previous term is, and then we're dividing by 2 each step. So this matches what's going on here. Okay? Hopefully you understand that. If not, please ask questions and make sure you're writing down these examples, because these examples correspond to the problems that are on the test. All right, now, explicit formulas and recursive formulas may look similar, but there's a huge difference. An explicit formula for a sequence allows you to determine the value of any term in the sequence if you know the term number for that term. Okay, it does not require any knowledge of the previous terms in the sequence. In other words, with a recursive formula, you have to know what the previous term is. With an explicit formula, you do not. Okay, the term number is typically expressed as n. Okay, so we have to write an explicit expression for the given situation. So the first row of a theater has 45 seats, and each subsequent row has 7 additional seats than the previous row. So the first thing to do is determine what your starting point is. This will be the first term in the sequence. In this case, it's a sub 1 equals 45. So we start off the same as we do with recursive formulas. Second, we need to figure out what's happening each step after that. And again, we kind of know this. The problem states that we're adding 7 to each row. So for like the first one, a sub 1, we know it's 45. So if we did a sub 2, we would use the previous row number, which in this case would be 1 for the second row, times 7. Okay, so and that would be, we would add that to the 45, and that would tell us that there's 52 seats in the second row, and so on and so forth. So we write an explicit formula for a sub n, and this is always going to be wherever you're starting off. So this would be the number that you first see, or where it says the first row or whatever. Okay, and then we say it's plus n minus 1. Now notice, the only time you see that little small n kind of offset and down, that a sub n, is right here. You don't see it over here like you did in recursive formula. So now we only take the row number that we're on, minus 1, and multiply it by 7. So like I said, if I wanted, and the good thing about this one is, let's say I wanted to know how many seats were in the fifth row. Okay, so I could say fifth row, and I do a sub 5, because that's the fifth row, equals 45 plus, and see how n here, that denotes the fifth row? That's the same thing there. So 5 minus 1 times 7. So that would equal 45 plus 4 times 7, which is 45 plus 28, which is 73. So there would be 73 seats in the fifth row. Hopefully you kind of see, how that's working there. All right, next example. Miguel has $30,000 in credit card debt. The balance is increased by 9% each month due to interest, and Miguel could only make payments of $300 per month. We need to write a recursive formula that gives the balance of his account each month, and then we need to determine the balance after 3 months. So recursive formula means that we're going to have that a sub n in there twice, and it also means that to find the balance after 3 months, we're going to have to find the balance after 1 month and 2 months. So first, determine what a sub 1 is. This is the first term in the sequence. That's that right there. A sub 1 equals 30,000. Determining what's happening each step. Well, now we don't have this series of numbers to go off of, but we do have information that we know. So the problem states his balance increases by 9%. Now remember, when you see percentage, that's exponential growth. Okay, so when it's growth, we take 1 plus the rate, which is 0.09, to give us 1.09. And exponential means it's multiplication. Okay, it's not addition. But he's also reducing his balance by a constant, meaning he's paying $300 each month. That doesn't change. So that would be minus 300 because he's reducing it. So we have to write a recursive formula. So see if you can do this one on your own. We know that it's going to be a sub n equals something. And we know it's going to have 30,000 in it, right? Okay, see if you can fill in the rest of that. All right, now remember I said exponential means multiplications, which means that we're probably going to be multiplying this 30,000 by this. But then we also have to factor in the minus 300. So we would write it as a sub 1 equals 30,000 and a sub n equals 1.09 times the previous balance. Okay, so whatever it would happen to be in the sequence before, minus 300. All right, so now we have to take that formula and figure out what it would be in the third month. So it's a recursive function, which means we need to figure out each of the previous numbers to determine the fourth term. Okay, the starting term is a sub 1, so that doesn't count as a month because that's what you start off with. After 1 month would be a sub 2. So starting amount, a sub 1 equals 30,000. We need to find a sub 4 because it's the third month. So with these problems, just remember whatever month or term they're asking for, it's basically you need to find one more than that. So in month 1, a sub 2, we plug in that information into our formula that we had up here. So 1.09, which is, since it's exponential growth, 1 plus the rate, which is 0.09. So we take that, add it together, multiply it by whatever the previous was, minus 300. So a sub 2, because this always matches here, minus 1. So whatever a sub 1 is times 1.09 minus 300. Plug in the 30,000 because that's what a sub 1 is. Okay? A sub 1 equals 30,000. So we basically just have to put that in your calculators now, and you'll get 32,400. So if you notice, his balance went up because he's not paying more than he's being charged for interest. So I have a feeling this trend is going to continue. So month 2, do the same thing. Same formula, except month 2 is a sub 3. So we do a sub 3 minus 1, which is a sub 2. And if you notice, we figured out a sub 2 up here. Okay? So we're going to plug that in now. 1.09 times 32,400 minus 300 equals $35,016. Okay, so month 3 would be a sub 4. And again, notice a sub 3 is this right here. So we're going to plug this in right there because that's 4 minus 1. So we take that number and plug it in like we have over here, same formula through all of the steps. So you've got to make sure you get the formula right. And that's going to give you a grand total of $37,067.44. So that would be your answer. All right, so now what I'd like you to do with these, take notes on everything, especially the examples. Write down any questions you have or anything you don't understand, and try the problems that I give you in the beginning of class tomorrow. Still ask for help if you need it, but not until you've tried. Don't just look at the problem and be like, yeah, I can't do it. So look at your notes, look at the examples here. The practice problems in class will be solved the same way. All right, so hopefully this second time around with the videos work. If you have any questions, please do not hesitate to ask. All right, have a good one.